All right, so formula for the OR, probability of S or T, is the probability of S plus the probability of T minus the probability of S and T, because you can't count the middle twice, as we talked about yesterday. You can only count it once, so that's why we got to subtract it one time. All right, so you should be able to, you got all three pieces, put them in the formula and go. No, in a probability format, and is when they happen together. Do we know the probability of when they will happen together? Mutually exclusive? What does that tell me? I do not know what you're describing, and I don't want to. Okay, scratch that from the recording. I don't want to include that. They cannot happen together at the same time. And if they can't happen at the same time, what does that mean about the probability? It is 0. Thank you very much. Can't occur together. Are you thinking about the dating version of that phrase? Okay. We had it first. You tried to steal it. Okay, so imagine a Venn diagram that looks like this. You see how event S and event T don't overlap at all? That means they are mutually exclusive. So, we have 7 over 13 for the first part. We have 1 over 13 for the second part. We know that the third part doesn't exist. Therefore, the probability that you're going to get S or T happening is what? 8 over 13. Now, did you know that because you didn't put a -0 at the end? Now, did you accidentally not write that, or did you not write it because it was a 0? Okay, all right. That I can deal with. Okay. Even what? Okay. Recording. They're in the bathroom. No, you do it in my life. And then go to the bathroom. No, I'm just saying. Be, do what you need to do for life so that you're not messing up my time in class. We'll see if we agree with that. We'll time you. Okay, so get question 9 done quickly. Go. Taking away nothing because they are mutually exclusive. Okay, now the other one said or also. It said the probability of S or T. So just, good call, good call, good call. Thank you for the correction. The minute's up. Doggone it. She's not back. All right, we'll try it again. Put it on another minute. See what kind of speed we actually have. All right. What do we got here? 0.78, which is 78%. That is true. Okay, standard number Q is tossed. We got numbers 1, 2, 3, 4, 5, and 6. The probability of getting 2 or an even would be the probability of 2 plus the probability of even minus the probability of 2 and even. Same formula, just got to figure out what to plug in. Do we know the probability, how many out of 6 choices, how many of them are 2s? 1. Oh man, another minute's gone by. Gee whiz. Give it another try. Alright, now, out of the 6 choices, how many of them are even? 3. Out of the 6 choices, how many of them are 2 and even at the same time? Only looks like 1 down here is 2 and even at the same time. Find the probability. Officially 3 minutes and 22 seconds.
You should add 29 seconds because you started it.
I did start a tad late, that's true.
Wait, did you see me?
I saw the reflection of someone with a white shirt and I took a guess. I don't know. Wow. Sorry to move on. What did we get as an answer? Kind of not, because we got too many other things going on. What? 3 out of 6 is also equal to 1/2. I don't care if you write 3 out of 6, 1/2, 0.5, 50%. Those are all the same thing. Question 11. Similar situation, but this time we're rolling an even number or a number less than 4. So we want probability of an even number plus the probability of a number less than 4 minus the probability of both. Do we know the probability of even? Sure we do. We just wrote down 3 out of 6 on the last question. How many of the numbers from 1 through 6 are smaller than 4? Yeah, I didn't want to write out a word like the number is less than 4. 3, you say? Why didn't you say 4? 4 is not less than 4, thank you very much. No. Intelligent, that's what that is. Oh, okay. Okay. Not sure that's how he really was trying to use it. Okay. And what's the probability that you're both less than? So out of the 3 that are smaller than 4, how many of them are even? What, 1, 2, 3, 4, 5, 6? 3 over 6. 3 over 6 and 3 over 6. Right? Because you guys told me that those 3 numbers were less than 6. Or less than 4. Okay? So, how many of the 3 numbers less than 4, how many of them are even? 1. So that's 1 out of 6. So please tell me the probability. What is the probability? 5 out of 6. Excellent. Well done. All right. You know, yeah, well, 12 is a little bit different. So let's jump down to 13 because it uses the same union formula, and then we'll come back. So there is a mistake in this question. I have calculated it earlier today, and they come up with a negative number if you use 2/3. So we're going to change this to 1/2. So please change it on your paper copy to 1/2. We know that we're dealing with the probability of A or B equals the probability of A plus the probability of B minus the probability of them both happening at the same time. That's the formula we've been using for quite a few of these questions. Do we have any of those pieces of information? What? Which one? 1/4. Okay. Yep. I don't know. Let's not. We'll talk about that in a second. Do we have any more pieces of information to put into this formula? What's that one say? 1/2. But we do not know the one on the far right of the equation, so we'll just call it X. Now, they are not telling me these are mutually exclusive. They are asking me, are these mutually exclusive? What is the only condition that you would say yes to? If something is true, then we're going to choose yes. If they can't happen at the same time, which I'm going to imply from what, no, I would infer from what he implied. I remember English class. Okay, I got really mad at the teacher one time for, no. The writer implied, the reader inferred. I was like, oh, I was hot. I mean, more so than I know. Whoa. Yeah, he might be. Oh, yeah, he's got that. Okay. What's a good common denominator for this? I don't know why I just put parentheses around that. I'm not going to get rid of them. What's a good common denominator between 2, 4, and 3? 12. Thank you very much. So we're going to multiply this one by 6. Multiply with this. Yes, I'm serious. Multiply this one by 3. Multiply this one by 4. Solve it. I know. Well, there were dangling wires, and they were taken out of the doors, but I'm like, I don't know why you start a project and not, don't at least finish it. They took the wires that they were dangling down that literally a kid could just walk and grab and pull down. They put them up in the ceiling. So now we just have to worry about the idiots jumping up to knock them down. Yeah, the lights. Hey. Okay, didn't you take care of this already? Okay. Well, did you get this solved, at least? Come on. Get it solved. Act like you've been here. Like what you've done so far. Okay, so what are we going to do with this thing? Yes, that is 7/12. We've added them together. We got 7/12. How do I get that to move to the other side? Subtract. Okay. So now I know that negative x equals negative 1/12. What do we know about the probability of A intersect B? Well, if negative 1/12 is equal to negative x, how about positive 1/12? All right, so what's my answer? Are A and B mutually exclusive? No. So here's the problem with it's frozen. I was like, why isn't it showing up there? Okay, put that thing. Are you done with that thing? Yeah, I had to open up some memory. Okay, so in this particular example, because they used 2/3, I showed that you ended up with a negative 1/12. There is no way to end up with a negative probability. Please listen. Please listen. Instead of talking. So I knew that they had a problem with the math. That's why I changed yours to 1/2. So that you would end up with a positive value. So they screwed it up. There is no way to get 0 is the lowest probability because that means something is impossible. And just like 1 is the highest probability because you can't go more than 100%. Okay, question 12, which is different than the others. But it does go back to like the pet example, the pet store example that we used yesterday. But this time there's a key phrase coming. A jar contains 4 blue marbles and 3 red marbles. Suppose you choose a marble at random and do not replace it. Unlike yesterday when they put the puppy back. Okay? Then you choose a second marble. Find the probability of the event, which is that both of the selected marbles are red. So we have our first draw and our second draw. The first time that we draw a marble, there are 7 total marbles. How many of them are red? 3. So, selecting a marble at random for my first draw is 3 out of 7. Does everybody understand that? Anybody not understand that? 3 out of 7 for the first. We must assume the first marble is red. Now, if we take that marble out and we do not replace it, how many total marbles are left? 6. How many of the marbles are red if you took the first one out and didn't put it back? Only 2. Only 2. Find me the probability by multiplying these together. This is similar to our pet store example yesterday, except these are dependent events. These are not independent. Okay, what do we get? 6/42 is an acceptable answer. Is there another version? 1/14? Yes. Is it 1/14 or 1/7? It's 1/7.
Wow, nice one.
Thank you. I think 0.143 is a good acceptable decimal if you're a decimal fan. Please remember, all of me loves all of you. Why couldn't Dracula's wife get to sleep? Nope. Because of his coffin. What's the difference between a dog and a marine biologist? What's the difference between a dog and a marine biologist? One wags a tail, the other tags a whale. What is the scientific name for a diagnosis of a chronic fear of giants?
Oh my gosh. Chronic giant phobia.
V5 phobia.